The 1 billion row challenge. I have been excited to break down this one for a while. There's been a ton of updates and a ton of crazy stuff going on. The quick TLDR was originally meant to be for the Java community, but it's since spread way further. And it's so cool to see all the things people have done to parse 1 billion rows as fast as possible in ways you never would have thought of. So let's dive in. Let's kick off 2024 true coder style. I'm excited to announce the 1 billion row challenge, the 1BRC, running from January 1st until 31st. There's now a 1 trillion row challenge, so if you still want to participate, that'll be linked in the description too. Might even get its own video. Your mission, should you decide to accept it, is deceptively simple. Write a Java program for retrieving temperature measurements from a text file and calculate the minimum, the mean, and the max temperature per weather station. There's just one caveat. A file has 1 billion rows. A text file has a simple structure with one measurement value per row. You have the name of the city, semicolon, and then the temperature. This isn't really a CSV. Thought it was. Regardless. The program should now print out the min, mean, and max values for each station listed alphabetically. So here's the minimum, the average, and the max for each of these stations. The goal of the 1 billion row challenge is to create the fastest implementation for the task, and while doing so, explore the benefits of modern Java and find out how far you can push the platform. So grab all your virtual threads, reach out to the Vector API and SIMD, optimize your garbage collection, leverage AOT compilation, or pull any other trick you could think of. Should I go do my own quick first implementation just to see how rough things get? Fuck it. I am very curious how big this file is. Only 24K for 1 billion rows. That's not too bad, all things considered. Let's start a new project quick. CD content, make dir 1BRC. Obviously, we're gonna make this bun. And up here, quickly paste the file. I am curious how and if bun can even handle this. Const text equals bun dot. They have the ability to get a file, right? Just this. Weather stations.csv dot stream. That gives us a readable stream. First equals text dot text. I guess if I want to put the whole thing in memory, I can just do that. I have to await it. Cool. Now we have that. I'll const text split equals text dot split on new line. And let's just see if we got the right length. That doesn't seem right. I thought we were supposed to get 1 billion rows in the file. That file only has 45,000 rows. Where's the one with 1 billion? Do I have a link to just download the 1BRC? I have to generate it? Oh God. Oh, I have to have Java for it. It's 12 gigs generated. Fuck. I do need Java to run the .sh. Can't believe I'm actually installing Java on my computer just for this. OpenJDK is keg only, so it wasn't symlinked. Remember when it said just clone the repo and you're good? Show us btop while doing this. Jesus Christ. Those performance cores are performing. Oh, cool. It's done. Only took 20 seconds. Where the fuck did it put it? Measurements.txt. Ah, and it's grayed out because it knows. Okay, I'm not even going to copy it because that might be too big. So I'm just going to move it. Someone said 12 gigs. Yeah, 13.8 gigs. Cool. CD content, 1BRC, bun run, index. This is just counting the number of lines. We're going to be streaming this one, boys. I don't think we can just get everything. Oh, I got a flash. That's a number. Notably, that's a number that's not 1 billion. That's non-viable. So he said open it in Z, and that's actually a phenomenal idea. So we can open this. It's fine. We can open up this. It's fine. Still scrolls really smooth, actually. What happens when I'm clicking it? Oh, man. Did this freeze it? No, it didn't freeze. It's just not happy. Yeah, I'm going to make this a stream and try this again. Cool. Text stream equals that. Then for const row or line of stream, we're going to let count equals 0. What's the easiest way to make something a big int in JavaScript? Is it just big int? Still doesn't seem to actually read all the file or all the lines. This is what I'm more concerned about. Here's what we'll do. If count equals 0n console.log line, just so I can see what one looks like. That's a lot more data than I would have expected in the first chunk. I thought it would chunk on new lines because I'm stupid. Yeah, chunks can terminate before the line ends. Yes. Yo, Nicole, for joining the T3 Club. Thank you so much for the support. I have to use the offsets. Ugh. But I don't know if the chunk ends before the next new line. That's the issue, is I don't know where things stand in terms of where the chunks start and end. Somebody linked a Stack Overflow for me. Oh, August. One of the few people I actually trust with this. Wait, yoink, yoink. I'm going to comment all that out. Cool. This was TypeScript. String, line, string, void, on finish, void. Cool. Let count 0n, count plus plus. Hide that on finish and change this to measurements.text. Come on. We really want to see that 1 billion this time. Oh, I forgot to log the count. Fucking Christ. Good point. Log count. Wait. Just use Rust, lol. How long will this take? That's a great question. Here, I'll add a check-in. If count... Wait, count's a big int, so you can't... Are you fucking kidding me? At the end, if I add the end of both, I don't think it will... Oh, fuck, it does. Console.log at count. Cool. Now every 10,000, we'll get an update. I need to add 2 zeros to that. Well, at least it's actually going. This looks fast enough. Like, this will get there in like 30 to 40 seconds. The logging is slowing it down, but not a lot. Since I shortened the length of that logging, it's not as bad as it would have been. But yeah, this ain't fast. I'll admit that much. This shit ain't fast. Oh God, I'm scared to look at the top submissions. But we're about to do whatever the opposite of a top submission is. Bottom submission? Fuck, am I a bottom? I'm trying to think, how do I want to data structure this so we don't have a shitload of values for everything? There's a hack for this. There's a couple hacks for this. Min and max are easy. Average is annoying, but I know how to do it. Okay, so the data structure. Trying to think, how do I want to make this a map at the outer level? I do, because I fucking love maps. So we'll do that. Const results equals new map. There's a type. Say string. I'll make the type definition for the location equals, it has min number, max number, mean number, and visited, I'll call it. So the type for here is string location, empty, const location, temp equals line.split, semicolon, const current equals, cool. We'll make our default here, min, infinity. I should get the temperature and then just set all of those there. Temp, parse float, temp string. That becomes that. That becomes that. That becomes that. And visited becomes... this will be 0 because I'm going to increment that. Wait, no, I would actually want these to be what I was doing before. This will be infinity. This will be negative infinity. Mean, it doesn't matter because it's going to be zeroed out. Cool. So current of visited. No, I don't want to increment that yet. We want to update these values. Const... making new values for this constantly is going to suck, actually. That's fine. We'll eat that. I don't want this to be a perfect solution. I want this to be a solution. So we'll go in here. We'll do min. Perfect. Mean. Thank you, Copilot. Cool. Looks like Copilot's very prepared for the 1 billion row challenge. Theoretically, that should work, right? Yeah. I don't see any reason why this wouldn't work. The big hack is by keeping track of visited, we don't have to keep track of all the values when we calculate the average. We can just take the current mean, multiply it by the total visited, and then add the temperature and then divide that. And then I'm just going to pick a random option in here to be the example. Can I find one that begins with an A? Agapa. Cool. We're going with Agapa. Console.log results.get Agapa. Cool. I might have it log the results for Agapa at all of these too, just so we can see. Oh, I didn't fucking console log it. See how long it takes to find Agapa if we even do. I will say it does look sadly as though Agapa is not in the generated output. How do I figure out something in here without crashing everything trying to open the file? What's the easiest way to cat just the first line in a file? Head, measure, what? That should work. Straight pain. Oh, I didn't actually change that. That's why. Why would this just randomly flip to nan at some point in this window? Parse float can error. There's no place where a divide by 0 can happen. There's nothing here that would be 0 that's in a divisor. There's just this. The only big int is keeping track of count. This isn't used for anything. There's nothing I know of that would cause a random... What? I do wonder if this is a bun thing, honestly. Fuck. If current.min equals nan. I guess I'll do this below. New visited dot min. How do you check for is number.isNan? I fucking hate JavaScript. This is how often I have to check for this, if you were curious. Why is that nan at that point? I'm just going to throw the first time it happens. Throw new error help. What the fuck? It's the input. It's the fucking input. Why? Why is this in the actual input? Open the file and find out. Yeah, sure. Let me just open the file. Yeah, this is Java's fault. How much time did I just waste trying to figure this out? And the problem was Java the whole fucking time. Search the 12 gig text file. You generate. Okay, I'll regenerate with the normal script. Cool. We'll do that in the background while I come up with some other hacks as we go. Pieces, const location equals pieces 0, pieces.length -1. Yeah, this initial test data is just trash garbage. Cool. That's the issue. But this is as much of an issue because this is going to take an hour to write everything. Does it do dash for missing data? No, because the dash can also be negative. That's just such an insane thing for it to have as its line. Okay, we're doing line, comma, location. I'm going to drop that all underneath, make it a little clearer. Console.log, additional info. Y'all are going to have fucking masterclass on debugging. Instead of doing that there, I'm going to comment this out. Do it here instead. If number.isNaN temp turn to skip all of that. And hopefully we won't have that problem anymore. I am parsing it faster than it's generating here. That's a good sign at least. 422 degrees max. Yeah, it seems like some of these numbers are weird. Whatever. I'm just using the data they gave me. Yeah, this will be done in like 10 to 15 minutes. Let's continue reading the blog post and see what other people did in the interim. The interesting thing of how they implemented this is they had everybody contribute their solutions to the actual repo. And once they were approved, they got merged, which interesting way of doing the contest. Cool, because lets them have an internal leaderboard, which we can take a look at quick. I'm curious how people's solutions performed. Okay, number one solution was 1.535 seconds. It used GraalVM, native binary, and it uses unsafe calls. This is Java code, which obviously I don't love, but we still dig through it. String file. They have a custom min and max. They did this wrong. The min should be a big number and max should be a small number. Max name length, max cities. Oh, is this so they can do weird like hashing range shit? Honestly, most of this is going to be weird file parsing stuff is my guess. File start, file end, atomic long cursor, list results. Okay, how do they split segments? Number of workers is available processes. The thing I'm trying to figure out here is the orchestration of the threads. They split by core count, yeah, but where are they actually splitting? Threads, list, all results, int, threads length, I, threads, new thread, results, parse loop, file start, file end, file start. Spawn worker. Okay, I'm just realizing now how long this is and how much of this is esoteric Java bullshit. This is not actually interesting to read if you don't know a lot of Java. And I know a bit of Java, but it is still chaos. Let's take a look at the discussion. Oh, somebody in Elixir. It's the most commented solution. Interesting. Oh, the person who did it in MySQL was insane. Okay, the 1 billion. The fastest somebody has for 1 billion is 36 seconds in Elixir. Did my code finish running yet? It did. I should have timed that. I really should have timed that. I'm only checking one of the results, but like writing the code to print everything out correctly is annoying, but not too much so. Just not something I feel like doing. My answers are correct. I know that. I'm a smart guy. Let me know in the comments if that's not the case. I do want to time this though. We will see how long it takes for Bun to run this. Interesting that basically all of the top solutions, all but 2 exceptions for the top 10, use GraalVM. If you're not familiar with Graal, it's a fascinating project. The goal is to pre-compile your Java VM code so it's native, so to speak. And it's really powerful stuff. It's one of the most promising developments in the Java world, and it makes sense that for Java stuff to be that fast, it had to come through Graal. Here's them running it on a much more powerful system with 32 cores and 64 threads. And some of these Graal solutions are now under half a second, which I know we don't associate Java with being fast, but when you need to be fast and you use these tools, you can get pretty fast. Someone in chat, Gabriel, of course, pointed out static Ermis would be very fun to do this with too. It would be chaos, but it would be. The catch is so much of this is like the file parsing side that I don't know how much like you'll be able to write JavaScript code that compiles to better file parsing. That I feel like you need to write a native library for regardless. My code is still running. We'll see how long it ends up taking. This is another blog post by somebody who competed really early on in the challenge, which obviously they used Rust for it. Let's see how fast they got. It'll be very funny if they couldn't get faster than some of those Java bits, but to be determined. So they're running it on Rust. External libraries are allowed at first for convenience. I'm assuming the set of cities is fixed, or at least that each row is sampled randomly from the set of available cities. Or really, I'm just scanning a prefix of 100,000 rows, assuming all of them appear. Use the longest line of the input file, which is 33 characters, and that cities are uniquely determined by their first and last 8 characters. This is an interesting assumption. It's crazy that these types of hacks matter as much as they do. I just grab a key and set a value. This post is a log of ideas, timings, and general progress. The processor that they're using is an i7-10750 at 2.6 gigahertz. Clock speed can go up to 3.6. Apparently they can run it to 4, but they run it at 3. Interesting, because they're not running it on the box that's being run for all of the tests. So I'm curious how this performs. It'll be very different from what that box will run. I wish they had that comparison. We'll see as we go. So after improving, the measured inside program time using 12 threads was 0.90 seconds. Not bad. Let's see how they got there. Oh, he links his code and his Twitter. Very convenient. Shout out to Ragnar for documenting his chaos here. This feels like something Prime would enjoy a lot. So let's see how he did this. 13 gig file, containing 10 to the 9th lines of this format. First, the city name. There are 413 cities, and each row has a name chosen from the set. I thought there would be more cities. That's good to know. Their lengths are from 3 to 26 bytes. Then a temperature formatted like this, possible negative number with one of 2 integral digits. The output is all of the cities sorted, each formatted with 1 decimal place. That's less bad than I thought. Now I know how few cities there are. I might actually go back and do that. This solution took 105 seconds. See if we can understand this. Count, min, max, sum. Count, again, that's the key hack for not having to store way too much data. Implement the record. Default self has this. Add, you increase count. You add to the sum. I guess they're doing sum instead of like maintaining an average because that's less calculations. You just add to the number, then at the end you can divide. But this also means this can overflow as a big int, which is annoying. My solution keeps the numbers lower. Then the average, which is F32, which is float 32-bit, self-sum divided by self.count as a 32-bit float. Now we have the main, take the file name where we grab measurements text, we create the file, open, unwrap, we read it to a string, create a hash map, and then we go through every value. Cool. You can see why this takes so long. Oh, they're even giving us flame graphs. Yeah, that's a lot of code running for over 100 seconds. Speaking of time, how long did mine take? 225 seconds. Not bad for JavaScript. Still pretty rough. Let's keep going down. Bytes instead of strings. Strings in Rust are checked to be valid UTF-8. Using byte slicing is usually faster. We have to do some slightly ugly conversions for byte slice back to strings for parsing floats and printing, but it's worth it. So basically removes the next match from the flame graph. How bad was next match here? Can't really see it in here. Why is it stored as an SVG when it's not actually an SVG? Interesting. Rust people and following web standards was never super aligned. Makes sense. Okay, here's the next match. So yeah, that is a huge chunk of this. Let's see what happens when that gets handled. Oh, you get down to 72 seconds instead of over 100. That's a huge change. 21 seconds saved. Not bad. Manual parsing. Now we're down to 61 seconds. Instead of parsing the inputs as F32 float, we can parse them manually to a fixed precision I32 signed int. This is crazy that they wrote a custom parse function to get the number in the shape they want. I hate this. I hate this so much. I will swear, this point in my life, I will never again write custom number parsing code. You just use the browser or whatever standard you have, because this is hell. After the hack of rewriting the int parsing, they inlined the hash keys. Oh boy. Currently the hash map is from string to record, where all the strings are slices of the input. The indirection is probably slow, so we should introduce the keys and store them inline. So U64. Turns out the first 8 characters of each city name are almost enough for uniqueness. Only Alexandra and Alexandria coincide. So we'll XOR in the length to make them unique. That's hilarious. So only checking the first 8 characters and then making sure they're the same length. And they have a toKey function here that takes in the name and it creates this unique key that's less data, so it has less stuff to deal with. Then he found a faster hash function from fxhash, which he used instead of the standard hash map, which seems to have been a pretty sizable jump from 50 seconds to 41 seconds. Dope. And now here's the updated flame graph. Figure 2, a useless flame graph. Yeah, everything takes basically as long. But since everything's inline, you don't get any useful info. Perf it is. Cargo flame graph uses perf record under the hood, so we can just perf report and see what's in there. Do Rust devs actually do this and read the address calls? This is crazy. I hope the average Rust dev has never spent any time in this type of perf reporting, because this is chaos. Good. Everybody in chat saying this is only for optimization. I will trust you guys. I really hope nobody's reading memory addresses in their debuggers nowadays. So the U88 to U64 is an unaligned read and it's surprisingly slow. Allocating the right size. Can stat the input file for its size and allocate exactly the right amount of space. This saves about half a second. This looks like it went up in time. But well, it turns out this is a non-inline function call, and after that, all things slow down. Yeah. mchar crate seems to be better than the default. If you use this crate, it's heavily optimized and goes all the way down from 40 seconds to 29 seconds instead. Very interesting that the line splitting logic for actually mapping the characters from memory is as complex as it is, but that crate could help that much. 1 more second saved by no longer checking bounds because you don't need that because you know how long this is. Manual SIMD immediately pushed it back up. More profiling done. I hate this so much. Revisiting the key function again. Then this pointer hash perfect hash function. God, this is chaos. Hash map takes a lot of time. There are 4 instructions taking over 5% here for a total of around 35% of the runtime. Oh boy. He used pointer hash, which is a minimal perfect hash function that he developed based on the point hash white paper. This is so much more in the weeds than I've ever cared to go. I'm very thankful there are smart people like this author and like theoretically some of the viewers of Prime, like 3 of them or so, that actually get all of this shit so they can make things faster for me when I use them in Bun without thinking about it at all. Yes, white papers are actually involved in getting this as optimized as it is. Insane. That got down to 17 seconds. Larger masks for handling character offsets seem to help a lot as well. Reducing pattern matching always breaks my heart. I love some good pattern matching, but I can see why it'd be useful here if you can kill a bunch of cases and make less work to figure out which case you care about. The generator that he uses was modified to always print exactly 1 decimal, which saves some branches. So part of this is generating the content as well as parsing it. That's a huge increase in how long his solution should take. Instead of first reading the file in the memory and then processing it, we can memory map it and transparently read parts as needed. Saves 2 seconds of time reading the file at the start. And then parallelization knocks it to 2 seconds. Parallelizing code is fairly straightforward. He says as a Rust developer, this is hilarious. If I know anything about Rust, it's not easy to parallelize. I'm happy it was easy for him at least. First, we split the data into 1 chunk per thread. Then we fire a thread for each chunk, each with its own vector to accumulate results. Then at the end, each thread merges its results into the global accumulator. He parallelized by splitting all of the chunks to their own vectors and giving each to a thread, and that basically gave him a 6x because he's running it on 6 cores. And accumulating is a small fraction of the total time. Makes sense. Branchless parsing helped lower it even further. The match statement on the number of digits in the temperature generated quite a lot of branches, and perfstat cargo run R was showing 440 million branch misses, i.e. almost every other line. It's about as bad as it can get, with half the numbers having a single digit, that's an integer, and half the numbers having 2 digits instead. He was able to pinpoint it to the branching by running the perf record-b-g cargo run-r, followed by perf report. That's fair. Branchless version is quite a bit faster, only 140 million branches missed. Checks out. Purging them all seems to have helped as well, but we're talking 1.7 to 1.67. We're nearing the end of how much optimization we can do here. I'm curious what other big optimizations he finds. Apparently he wasn't actually using the custom hash for certain things, and he added it back, saved some more time. Accidentally dropped a -b0 part when making the floating point parsing branch free. Adding them back bumps the time quite a bit, given that it's only 4 instructions. Assuming all temperatures are less than 100 helps out too. So a lot of assumptions and hacks here. Not parsing negative numbers. To skip negative numbers, he created a separate hash map entries for positive and negative numbers. In particular, for cities with negative values, they'll act as if the separator was located at the position of the minus. That way, the value is always positive, and the city name gets a semicolon appended for negative cases. What? Overall, it's pretty much performance neutral. Yeah, this is chaos. Min-max without parsing. Interesting. Just comparing the raw bytes. Somehow ended up being slower. Parsing using a single multiplication does work after all. Guess he's doing bit shifting now to get the right data into memory. That's insanity. This is the level of optimization here is absurd. Arbitrarily long city names, 4 entries in parallel, mmap per thread, reordering some operations helped, reordering more helped. Even more ILP helped. Compliance 1. Okay, I'll count. 106. I think back the record counting. Being non-compliant this way is annoying, and it's really quite brittle to rely on the randomness here. Surprisingly, performance is much better when I make the count a U64 instead of U32. Didn't bother to figure out why. Interesting. Great work to the author for making this work in the chaos that is Rust. Holy hell. Good friend of the channel, Ethan, shared his solution in Elixir. So first we get the data frame, which is a helpful Elixir package for getting data from a file. Here we specify the delimiter, create this helper that we can use to do things like grouping. We also assign keys here. This isn't quite how I would do it, but I also just am not as familiar with Explorer and the cool things you can do with it. As per usual, Ethan's on just like a whole different level. Explorer is so cool. It uses polars, which is Rust. Ryan Winchester is being incredibly helpful. I also did not know you could do this with Elixir. This is going to be a fun one to trim. Again, I am so sorry phase. You got to keep at least one of the I'm sorry phases in this video as well, by the way.
Oh, that's okay, man. That's what I'm here for.
But I want to see how other people solve this in Node, because as I showed previously, my Node solution was not ideal. And I even used bun, so I was kind of cheating. But here are the solutions others made in Node. This one only took 23 seconds. This one took 6 minutes. Both of these are actually by the same person, which is cool too. Were there just not other submissions for the Node one? I would have thought there would be more Node examples. Let's see how the optimized solution here actually works. Look at the baseline. This is the baseline Node solution. Get the file name from the argument. We create a read stream, readline.create interface. Ooh, there's actually a readline package in Node. You know what I'm going to do? I am incredibly curious as an individual. So we're going to do node edition.js. Paste this. Bun run node edition.js, and this needs the input of /. We'll give it the shorter CSV first. Bun does not like this. Huh, that worked, and it was actually kind of fast. Interesting. And if I change this to measurements.text, I want to time it. Let's see how this goes. The baseline was 6 minutes. Hopefully it won't be quite that bad on my computer, but we should take a look at the optimized version. Oh boy, we're already seeing where these hacks come in. Max line length is a big one that a lot of other people seem to use. The semicolon character code, as well as the new line character code, so they can parse lines using character codes instead of actually translating to string. Very interesting. Token station name is 0. Token temperature is 1. So that's how, once it's split, it knows what's where. Nice to just have these hard-coded as names, but interesting choices. This is a debug helper that tells you how many threads you have. And now we have the actual map. That's the definition for the map type, which again, min, max, sum, and count. Familiar? If worker threads dot is main thread, file name is process, arg, second argument, files await the fsp dot open. Oh, that's file system promises. Size is await file stat dot size, thread count, CPUs dot length, chunk size, math floor, chunks offset, buffer find, alloc, while true, offset plus equals chunk size. Interesting. So we have the chunk size, which is the total size divided by the number of threads we have. Then we're dealing with an offset because the chunk's not going to end perfectly on a new line. And yeah, while true, we offset plus equals chunk size. If offset is greater than or equal to the current size, then we push this offset so that we can be sure every chunk is the right length. Yeah, file.read 0 max line length offset. This is the buffer that it's being sent to. Starts at 0, go up to max line length, and then the offset. I need to know the arguments that file.read takes in Node. Looks like we're not getting an answer using this in Node. Fun fact, the reason I started using bun more was because I kept running out of memory when using Dino, and bun didn't run out of memory, so I used that instead. And I can't run bun for this, right? No, actually seems to be tolerating bun this time. We'll see if that goes. Interesting that it's using workers to process things. We create worker threads for all of the chunks we have. We import the current file as the content for this worker, and we give it this additional data. This is after we've parsed it. We have the key, which is the location, and the value, which is the min, max, and everything of a given entry. And we can compare that to what we currently have and just add everything else together. This lets you do like crazy threading, so you never have to worry about the order of things. So you're just combining all of the data you've collected in all of these different workers, and it comes out correct because this all works properly with something. Like no matter what order you do things, the minimum's still the minimum, the maximum's still the maximum. And since they're not calculating average the traditional way, they're calculating it via the sum plus count. This works too, and then you can just calculate the average at the end. And once stopped workers is the same as the length of chunk offsets, which is the number of threads you're processing, you can print the completed result. What's this if-else wrapping? Okay, so this is if it's the main thread, because this is all done through workers. It's the same JS file for all of it. So if we're on the main thread, which is the one that orchestrates all of these processes, it does all of this work to split up the workers based on chunks and line ends and such, and then creates these worker.on calls. else, and this is a big else, I wouldn't have written it this way because it's important to recognize the difference between these cases. This else specifically means that this is now running in one of those workers. You can almost think of these like this should be a different file, so to speak, because this lives in its own world. But the worker thread has data on it. In this case, it has a file name as well as a start and an end. So if start is greater than n-1, then we post a new map, which means we just give it an empty map because this is like an escape, which allows you to still combine things properly. Otherwise, we create a read stream, which starts from the start point we were given and ends at one character before the end. And we call the parse stream function. So this is the thing that started the worker. We post the message, and that allows it to all be collected at the end. Reading this helps me better understand why everybody makes fun of both workers and async in JavaScript. The amount of chaos here for orchestrating these things in parallel is just hilarious. I want to go to another Elixir example to compare against because I think this is something Elixir does genuinely like hilariously well. Don't tell me he went into Erlang. That doesn't count. That's cheating. Elixir exists because nobody wants to read Erlang code. Let me see this in actual Elixir. The mix and the create. It's cool they have a create that's in Elixir, so you don't have to create everything in fucking Java. Just nice. Interesting. They have multiple options here. Parsers. Very interesting. Everyone's calling Erlang directly, which is terrifying. Here's what I wanted to highlight though. The ease of spinning up things like workers in Elixir is just hilarious because the Erlang VM is so good. Beam is just dope. So here I enum.map, which is the equivalent of like a map call. Here I am creating the range for this map. It starts with 1 and it ends with hash space, which I believe is the number of logical processors that you have to work with, times 8 because they have so much threading in Beam. So this will be the number of cores you have times 8. Now it has the ability to spawn links, which are kind of like workers here, for all of those. We just map the range we want to cover. We have this function that returns a spawn link, which returns this worker main call that does whatever work. Now we have workers, which is doing all of these things in their own separate processes, and we can pipe values from it if we want, or in this case, we can read file by passing this file that we got from the file open call here to the workers, which is a lazy stream that will load in with all of the data, one chunk at a time here, gets spread across the workers. Just beautifully simple. Read file. Do okay is do read file. Enum map workers, receive, check. And here's the do read file, the actual place where the work is done. Bins, case, read line, file is over. Then we bin. This is some nice little pattern matching. If the result of this do is EOF, then we call bin, which is just the thing we started with. We return that. Otherwise, we pattern match with okay, comma, line. That means we have a new line. And we return this as a binary line, which we can then parse later. And when we want to display this, this is just going to return an array as my assumption. Starts with the bracket, results. It maps results into enum map, splits it with this, which is the weather station, just the name, comma, and then all the values. This looks a lot like the unbundling you might expect in something like JavaScript or TypeScript. But where we go with it is where things get interesting. Pass WS equals. This isn't even that interesting. This is just dumping and converting things and giving us an output that we can use. And then intersperse, which takes the results here and puts comma space between them all, and then an IO outputs at the end. I fucking love pipes. Hope this helps highlight why. We take results, we do this to it. We take the result of this, we throw it here as the first argument with intersperse, and then we pass that to IO outputs. Dope. I fucking love Elixir, man. Not bad. 9.23 seconds user side. That's not bad at all. Pretty cool that Explorer can just parse a CSV and you can specify things like column 1 is the category and then column 2 is this shape, which is a 32-bit float, my assumption. Lazy true, which means that it will chunk things as you grab them. End of line delimiter, so you can get end lines. The delimiter for how things split, this could be that or comma if it was a traditional CSV, but it's a CSV using semicolons, which makes it not a CSV, separate rand. We rename these columns to station measurement. We group by the station. And then we summarize by getting the minimum for measurement, the mean for measurement, and the max for measurement. We then mutate by rounding all of these values. We sort by the station. We collect. This call is important because this is all lazy up until this point. So all of this is being evaluated as requests are made or when you're trying to pull values off of the stream. Collect says, fuck you. It's all a collection now. We're done. We then create a row stream from that. Just funny, we're making it not a stream and then making it another stream, but a different type of stream. Then we map that stream to this text format, and we join it, and then we print it. We can also join this with that instead, and now it'll make a new line for all of the outputs. Fuck, I love Elixir, man. This language is so good. Somehow that was even faster. 4 seconds somehow. Nuts. Being able to parallelize in pipe and do all of these things is nuts. Oh, EXS is compiled every time you run it. So that's being included too. Very good to know. That means it's even faster than what this is supposed to look like. Yes, the first value is the lowest temperature, the second value is the average, and the third value is the highest temperature. So yes, the first should be negative sometimes for places that get negative, and the third probably shouldn't be for many places. Yeah, rounding is hard. Yeah, this is honestly probably my favorite solution of all the things we've looked at. So thank you, Ethan, for writing this as quickly as you did, and then spending 3 times more time trying to get it running on my computer. Good stuff. Interesting that MySQL is as much slower as it is compared to both Postgres and ClickHouse. If you're not familiar with ClickHouse, it's a database specifically built for doing large amounts of data querying. That's a rough header. Following is not a benchmark. The test is done with default installations of both databases and no optimization. So that's a Postgres. Pretty boring calculation here. You go through all of the rows once they're in the database. You select the city, the min temperature, cast average, max, from test, group by city. Pretty boring, standard stuff. Takes 8 minutes, which is hilarious, but at least you get a result. Most of the time is spent copying the data, and only 2 minutes, 51 seconds are actually doing the aggregation. So if you start with it, it's only 2 minutes, 51 seconds, but you have to get the data into Postgres somehow, or this is useful. But then we have the foreign data wrapper. I know the foreign data wrapper is something that the Supabase team's been deep on, trying to make crazy performance possible within Postgres. Curious how that ends up going for them. But here they're using it so they don't actually have to make the file contents part of a database. They can read it as a foreign table coming from the measurements.txt file. This is actually about a minute faster than having to copy all the data over directly. But then we talk about ClickHouse, which again is really fast for large amounts of data processing. That's what it does well. If you're looking up individual things, it won't be as fast. But when you're trying to do giant queries across things, it's very good at that. You can query the measurements text file by actually passing it measurements.txt, CSV, and you tell it first value is city, second value is measurement, and he limited 5 here. So you see, you get values. That's really nice in ClickHouse to just create a table out of a CSV effectively. And again, same query roughly as before. The main difference compared to Postgres is that they use group array to create the list of cities. See the order by city in the first query to order them correctly. Yeah, so order by city here. Yeah, select array string, group array city or equals or concat. The array string concat to concatenate the array and elements into a string. That part makes sense. The group array is the interesting bit here. See the order by, order them. Okay, so we're ordering and then we group the results after and then print it. I think that makes sense to me. To get the timing, executed the following. I called it with the time call, passed the values in. The results, 44 seconds. That's pretty good. Not bad for a SQL solution, which is not meant to do this. And as he said again, that's not a benchmark, but it's still very interesting. Same author. Results are much slower than Postgres and ClickHouse. Yeah. I am curious if anyone has made suggestions on how to make this faster. Timings 43 minutes and 58 seconds with over 33 minutes and 32 seconds on the ingest and then 10 minutes on the query. The database became 40 gigs, which is 4 times the size of the original measurements.txt. Yeah, if anybody watching has an idea of how to make this both run better in MySQL or why he was having issues, the link for this will be in the description for sure. So you can check that out and find him on Twitter because I am actually very curious if we can make MySQL a faster solution for this. I'm not putting this in this video, but I want you all to know there is a 1 trillion row challenge that was meant to be a follow-up to see how you can process an amount of data that's almost unfathomable. The data is stored in Parquet on S3. Each file is 10 million rows, and there's 100,000 files. There's also the ability to generate the data yourself, and they have source code for that if you want to. What are the languages people are using for this? It's all Python. Very interesting that the Python community is going all in on the trillion row challenge. Curious how that ends up going. Yeah, if you want to hear more about the trillion row challenge, let me know in the comments. So, a lot of interesting conclusions here. First off, Java's way faster than I thought. Second off, basically everything here was file parsing related. Most of the challenge was finding a way to get the data from a text file into your code and language, memory, whatever you need in an efficient way such that it could both be processed quickly and also multi-threaded. Not a fun challenge there. On top of that, God, I did not think solutions like ClickHouse or Postgres would be viable, much less decent. But yeah, here we are. Java's still kicking. Graal VM is better than I expected. Rust optimizations are utter chaos. And I hate threading in JavaScript. I think that's a pretty good set of conclusions for a video. Shout out to my editor for figuring out how to turn this mess into a video. Give him some love in the comments too. Until next time, peace nerds.